Welcome to the practical C# 6 talk. I can see some familiar faces already, so I'm just going to introduce myself briefly. I'm Sasha Goldshtein. I live in Israel, and I work for a company called Sela. And this talk is on C# 6, and what I've tried to do is kind of make it a little more interesting by showing you how you can take existing code and start to benefit from adding C# 6 features to it, and not just, a syntax review of what we have coming up in the new language. Another thing I tried to do is gather as much information as I could about what's coming next, about what's going to happen in C# 7 and possibly even beyond that, because C# 6, it is new. It's not even released yet, but it's kind of old. We've been told about some of these features about 2 years ago already, and in some cases there haven't been even any significant changes to the feature design, so some of these are really not quite new. Now I realize we're not using them in our everyday C# code because they haven't been released as part of Visual Studio yet, and that's part of why this talk sort of try to show you how these features can be used in an existing code base. So what I did is take a Redis client developed by Stack Exchange. It's an open source implementation of a C# Redis client, sorry, Service Stack, not Stack Exchange, and then try and add occasionally some uses of C# 6 features. So just to give you just this general idea of where C# is going and where we're coming from, this is the evolution of the language since C# 2.0, which is the second version of the language, the third, if you will, if you consider C# 1.1. And so C# 2.0 main feature was generics. We also had anonymous methods and a couple of other things concerning delegate contravariants, but basically generics. C# 3 was really lambdas and link. The key features were lambdas and link, and that was a huge release, right? After C# 3.0, you had lots and lots of new features to learn, and reading new code was rather difficult at first. C# 4 introduced dynamic, which is an okay feature, but I bet you're not using it every day, at least most of you. And there are some additional smaller features as well in C# 4. C# 5 has async and await, which are huge, and for some kinds of applications, you're probably writing async and await every day. In other apps, maybe not so much. And so the question we all had a couple of years ago was, what's next for C#? So what kind of huge, big feature they're going to tackle next? And many people had their own suggestions and ideas. For example, many people from the functional languages side were pushing for more FP-like features in C#, especially influenced by F#, stuff like records and tuples and pattern matching and a bunch of type constructors, a bunch of other interesting things. But none of these are actually part of C# 6. There isn't a single huge breakthrough feature in C# 6. It's a set of smaller improvements, incremental improvements to the language. Some of them were driven by customer feedback, people asking for these features for a while on user voice and other forums online. And some of these features Microsoft just sort of came up with on their own. The C# design team has been meeting every week for a while now. And they have a pretty good idea of the direction of the language, but there isn't a single big thing that I could tell you, this is C# 6. There's a bunch of smaller features. The biggest focus, though, was on developer productivity. So many of these features really have developer productivity in mind. And what I'm going to do, actually, for each feature is try to show you the old version of the code as you'd write it in C# 5.0 and what you can do in C# 6 to make yourself and the code more readable, more productive, and so more efficient, and so on. And again, as we go along, I'd also like to show you maybe a few examples in Visual Studio 2015 as we take existing code and sprinkle around some of those new features. And one more thing before we get started, I do have to mention the Roslyn project. So really, Visual Studio 2015 puts an end to a very, very long development cycle inside Microsoft of the Roslyn project. And Roslyn is a re-implementation, essentially a rewrite from scratch of the C# and Visual Basic compilers in C# and Visual Basic. The former versions of these compilers were written in C++. And Microsoft still maintains those older compilers written in C++, but Roslyn, the project, was partly about building a C# compiler in C# and a Visual Basic compiler in Visual Basic. And along with other things, it helped Microsoft really refine their understanding of those languages' corner cases and how these languages can be used for a huge production code base. Furthermore, Roslyn is not just the compilers, it's also a platform for building code analyzers, for building refactoring tools, for building code fixes within the Visual Studio editor, for extending the editor itself. So there's a bunch more things you can do with Roslyn, but what I wanted to tell you about right here is that the new C# language, the new features in C#6 are so small and incremental, I think, partly because Roslyn was such a huge project and they wanted to get it out of the door. They really wanted to get it over with and then start thinking about the next huge feature for the next version of the language. And again, it might be coming in C#7, but in C#6 there is no such huge feature. One more thing before we get started is that Roslyn, the compilers, are all open source now. Since November, they're open source. They've just moved to GitHub, and you can go and get yourself your own impression of the product. If I just quickly open a browser and go to the Roslyn project on GitHub, you'll find first that it's pretty active. So if I go to the pulse section, there have been, over the last week, 94 commits, excluding merges, on master, and 230 commits on all branches. 978 files have changed on the master branch with dozens of thousands of additions and deletions. There's a bunch of people working on the project, and not all of them are Microsoft employees. There have already been contributions from the outside by Microsoft MVPs and other people with no association with Microsoft. So it's a really impressive thing, this open sourcing of the C# compilers. But again, I think it's partly the reason why the language didn't get as many cool, exciting, huge new features. So let's get started with a couple of them. Now, if you have any questions, then please ask, because we're going to be moving from one feature to the next, and they're not all interrelated. So if you miss something, we might not have another point where we come back to it. So the first feature I want to show you is a really small one, but a very useful one if you've been doing async and await, and that's support for await and catch and finally blocks. Just as a general reminder, await is a really useful keyword for coordinating asynchronous work. And so, for example, in this code on the left, we open a file asynchronously, and then our code continues when the file has been successfully opened. And then we do something with the file, and then an exception occurs. And what we'd like to do in case of an exception is log that exception to the log and also close the file. But unfortunately, we can't, inside a catch block or inside a finally block, invoke additional asynchronous operations and await their results. So we have to write this really contrived code like this. We have to store the exception in an external local variable, and then we have to, if it's not null, await outside of the catch block. And instead of using a finally block to close the file, I have to put the file in an external local variable, and if the file isn't null, if I've successfully opened it, then I can, outside of this whole block, await the close method. So it's really weird, and I mean, in UI applications, for example, I've been doing this for a while, and it's really annoying to keep writing this code again and again. You can obviously abstract this away behind some helper methods, maybe, but there is no syntax support in the language to make this more expressive. And it's for a stupid reason, really. Microsoft just initially in C#5, sorry, didn't figure out, the compiler team didn't figure out how to support await in catch and finally blocks. And then in C#6, they did. They did figure it out. And so in C#6, you can do the natural thing. For example, you can have a catch block in which, if there was an exception, you log it to the log, and you await that asynchronous call. And similarly, in a finally block, if the file is not null, then you can just await the close method, the close async call on that file. So it really simplifies a lot of code. It means you don't have to use all these external local variables as much. And obviously, it's going to be more natural to explain to newcomers. If you explain a wait to someone, and then you have to explain, but wait, if you're using try-catch, then you have to use this other pattern. It's going to be annoying, and you don't have to do that anymore. So this is a really small one, but it does improve my productivity anyway. It hasn't improved much yet because I can't use Visual Studio 2015 on all my projects yet, but I bet it will at some point. The other thing, the next thing I want to talk to you about, and that's a set of features, have to do with simplifying property and method declarations. And here I will show you a quick demo later of how you can easily refactor existing code to take advantage of that. So here on the left, we have ourselves a class with an auto property called center. It's public. It has a setter and a getter, all public. And the constructor assigns a value to it in case it wasn't provided by the caller. And you can imagine more constructors down the line here, a constructor that takes coordinates for that point, and so on and so forth. Now, this part is kind of annoying. You have to assign to that center property in the constructor because it's a property. So you can't initialize it in line. But now you can. So in C#6, you can say, right next to the property declaration, assign new point 0, 0. And this is just magically injected into constructors as necessary. So the property is initialized to 0, 0, to the 0, 0 point, unless you change it elsewhere. Again, it simplifies code. It makes it more readable. It makes properties look even more like fields, which is by design. We really want properties to be as close to fields as possible. And for auto-generated properties, for auto properties, where you don't declare the backing field, it's even more obvious that they are almost like fields. So that's one example. And we have a bunch of similar features as well. For example, here's a read-only property. And you probably have a few of those in your code base, right? So you have a read-only field in your class. And then you have the property itself expose only a getter around that field. And then in all of your constructors, you obviously assign to that property, to that backing field, a value. And of course, your class always uses the backing field for any mutating for any changes. In C#6, you can use read-only auto properties, and you can initialize them even, and you can even write to them from within your constructor. So for example, here, center is declared as an auto property with only a getter. It does not have a setter at all. Not a private setter, not a setter at all. It's initialized with a new point 0, 0, which is the previous feature we've already discussed. And the cool thing is, from within the constructor, I can treat the property as writable. I can assign to the property, even though it does not have a setter. It just directly accesses the backing field for me. And really, it doesn't make sense to put restrictions on this, because the backing field is read-only, exactly the same way it is on the left. And here, I'm just assigning to that backing field transparently through the property. So you're not forced anymore to declare that backing field yourself. So for properties, that's pretty good news. For standard auto properties that you can now assign to in the declaration, and for read-only properties, for read-only auto properties, which is a feature you simply didn't have before and can save a lot of typing. Again, in lots of cases, you'd have these read-only fields and get-only properties littering your classes. So are we good so far on the property front? Yeah? OK, so here's another one, and I'm going to show you a demo right after this one. And this one's called expression-bodied members. It's essentially an alternative syntax for declaring methods which are simple, which only consist of a single expression. So here are a few examples of such methods currently in C#5. Here's a static operator, which I bet you've implemented a few of. Here's an indexer with a get-only indexer. And here's a read-only property, right? Now, these are simple expressions inside. The return statements are just simple single expressions, not statements. And we can write them in C#6 in a more compact form. this little arrow, the same arrow we use for lambda functions, for lambda expressions, replaces the curly braces and replaces the return keyword. So basically, it's an expression-bodied member function, member method or member property, because we take the expression that was returned and we simply put it there on itself with no return statement. So we have the operator declaration in this compact shape now. For indexers, this means it's going to be a read-only indexer. For properties, it makes a read-only property. You cannot declare a read and write property this way, or a read and write indexer. So whenever you use this syntax for indexers and properties, it's declaring a read-only one. But it's still incredibly useful. And again, it just looks so much cleaner once you see it, right? I mean, I hope. At least for me, it looks a lot more cleaner once you see it once or twice than all these curly braces nonsense that we had to write just a few minutes earlier. So let me try to show you a few examples of applying this, just to kind of see in how many situations this would be applicable. So this is the service stack Redis source base, and I'm going to be making a few changes here. But this here is one example. It's a class called Redis client sorted set. By the way, if my Visual Studio looks a little slow, I'm working with a virtual machine hosted in Azure because it's a preview version and I didn't want to wreck my own machine. So it might be a little slow occasionally, but so far it's been working OK. So Redis client sorted set is a class that's essentially a proxy, a forwarder, to another class which it contains a reference to. The internal thing is called client, and pretty much every method on this wrapper is a forwarding operation to the internal client object. You can see multiple examples of this here around the clear method, the add method, the contains method. So we're just going to start, refactoring these guys. There's one, and there's two, and there's going to be three. And we can keep going, of course. And I mean, isn't it just so much prettier now? No braces, more code fits on the same screen real estate. Now, this here isn't really an expression anymore. It's two statements, and this would be rather difficult to rewrite in this kind of expression-bodied form. And we don't have to. But for one-liners, this is incredibly effective. And I mean, I really find it hard to go back to the old way of writing methods once you see this. So any questions before we take a look at a couple more features? Yes, sir. So what? I'm
guessing the IDE can't do some of this refactoring for you. It seems like something that would be quite nice.
Sorry, I'm really sorry. I just can't hear you. Could you?
I'm guessing Visual Studio can't automate some of this refactoring.
OK. Visual Studio presently does not offer these refactorings. But yeah, conceivably it could. Thing is, I'm not sure I would want this to be, hanging over me. Well, you mean it as an optional refactoring. I wouldn't want it to be a squiggly thing. That I'm sure of, right? Because there's still room for curly braces. But yeah, as an optional refactoring, it would be nice, like extract method or whatever. It's not there yet. I'm betting it wouldn't be extremely hard to write using Roslyn. Because it's just recognizing this really simple pattern when you have a return that returns the whole method body is a return statement with a single expression. It wouldn't be very hard to implement, I bet. Could be a nice weekend thing. OK. So let's take a look at a few more, and then some more examples maybe. This is a great one, which again can improve productivity considerably. And it's called null conditional operators. So I bet at some point you had to write code on the left, like on the left, or something similar. So we've got this parent property, which could be null. And if it's null, we return null. If it's not null, then our parent has additional siblings. So we access that. And that can also be null. But if it's not null, then we just return the first one of those. So there's like 1, 2, 3, 4, 5, 6, 7, 8 lines of code. And if you use the other brace style, then it's going to be even more lines, which I haven't here. So in C#6, you can simplify a lot of these situations, and I'll show you multiple examples of that using the null conditional operator. So this thing becomes a single line. And again, all those ifs are gone. So what this says here is that if parent is null, then I want the whole expression to be null. If parent isn't null, then let's see if the sibling's property of that parent is null. If it is null, then again, I want the whole expression to be null. That's what the second question mark means. If it wasn't null, then again, like before, I'd like to return the first one. Now, the beautiful thing here is that it does the caching as well. So if the parent property is computed, if the sibling's property is computed, it will cache them. It doesn't do an if and then access the property again. It does what I did here. It caches the access and checks. It caches the access and checks, which means it's exactly as efficient as what you'd write by hand, but you don't have to write it by hand. And just imagine having 5 of those in if form, right? So whenever anything here along the way becomes null, the whole expression is just short-circuited to null. Otherwise, you keep testing until you reach the final result. So that's the question mark over here. You can put this in front of a dot for member access and for method invocations. You can put this in front of an array subscript operator to access indexers and to access arrays. You cannot, unfortunately, use this with delegates, and we'll get to that right away. We'll see what you can do with delegates. But this is extremely useful. I hope you can see how. So let's take a look at what happens with events and delegates, which is another really useful case for this. So I assume at some point you've had code similar to this. In GUI apps, for example, it happens all the time. So you have an event which is exposed publicly. So you copy it over to a variable to make sure it's not mutated. And then you check if it's null. And if it's not null, then you invoke it, right? You write this, some of you, I bet, write this every day. So this is one thing I'm going to help you rewrite momentarily. Another example is this thing over here, which is slightly more complicated than the previous one. So here I want to say, if the children array is null, then return 0. Otherwise, return the length of the children array. So it's not exactly the same scenario as before when I want null returned. Here I need a fallback value for that null. So here's how we can write both of these. For the event handler case, I really want to test whether the event handler is null and then invoke the event handler. But I can't just omit this .invoke part. I can't write e question mark open parens and then this whole thing because it confuses the compiler. I mean, it's ambiguous syntax. So we do need this invoke call. And as you recall, delegates and events always have an invoke method, which has the same signature exactly. So it's just syntactic sugar. And here we're desugaring it, right? We're calling the method explicitly. And this whole thing is still much cleaner than spelling it out and doing the if test. By the way, now that I look at it, this should have obviously been clicked and not e, because e isn't declared. So it should be clicked, question mark, .invoke, and so on and so forth. But again, much shorter than the other option. For children count, it's even nicer because we can also use the null coalescing operation, which was introduced in C# something, I think 2.0, if I am not mistaken. So here goes, expression-bodied property with only a getter. And then if the children array is null, then the whole sub-expression here evaluates to null. If it's not null, then the whole sub-expression evaluates to length. Great. And then if this whole sub-expression was null, then we return 0. Otherwise, we just return the value of that expression. And that's the purpose of this double question mark operator. It's not new. It's been around for a while now. But this syntax here with the question dot is new. So it's going to make writing these ternary conditionals much easier as well. So what do you say about the null conditional operators? Any questions so far? Yeah.
There's a spread set
What's that?
Is it thread safe? Probably
Is it what?
thread safe.
What?
Is it thread safe?
Thread safe. Which part?
Like if you check if children's null.
The check if children is null. Well, again, it caches the thing that you're testing. Sorry, no, it's not a property here. So yeah, you're testing if this thing is null and then accessing the lens. Yes, it's thread safe. It's putting the sub-expression here in a temporary, which you're not seeing. It tests if that's null, and it does the access on that temporary. It's a reference anyway. Yeah. OK, so why don't we look at a couple of examples, again, in that service stack Redis client, where it's kind of useful. So I have queued Redis operation over here, and you'll immediately see why I picked this example. Just look at this, right? If this event isn't null, then invoke this event. If that event isn't null, then invoke that event. It's horrible. I mean, it's a bunch of those ifs, just one after the other. Now, there is a subtlety here, because we are testing, and only if it's not null, then we're doing this. But at least this can be refactored, right? So I can do a .invoke here, like that. And obviously, the same thing here with all of these. So question mark invoke, and another one of those. Now, this is another example of a situation where the refactoring question might be relevant. So yeah, I would expect at some point there be a refactoring that would refactor those if checks and invocations for me, especially for delegates and event handlers, where it's pretty obvious what the final shape of it should be. But there isn't right now. So right now in the Visual Studio IDE, there isn't a special refactoring just for this feature. And actually, if you look for this pattern of if something not equals null, then something, using even a regular expression search, in this solution, you could find hundreds of occurrences. So just think of all the opportunities for simplification. I am not saying, by the way, that you should take all your C# code and start doing these simplifications and replacement. I am saying that the end result looks clearer, so if you write it up front with C#6, it's going to be more maintainable, probably. OK, so let's take a look at some more. There's more in C#6, but they're all roughly the same size, bite-sized chunks of syntax. Next one's string interpolation. And this is really syntactic sugar, but it's going to be quite nice. And lots of languages have this built in by now, especially the cooler ones like Python and Perl. So why not C#? The code on the left is just your standard string formatting stuff. So console write line does a string format for you. String format explicitly takes a format string and additional arguments for replacing in that string. C#6 has this as built-in syntax. And the syntax for this, by the way, has changed along the way. They were playing with multiple options. They were thinking of multiple ways of specifying those replacement characters for putting holes in the format string, essentially. And finally, it would seem that this is the final C#6 syntax. So you have strings starting with a $sign. And then inside that string, curly braces are interpreted as holes, where you put expressions. So for example, where there used to be a hole for the type, there is just the expression itself, type. And where there used to be a hole for count, there is simply the expression count. So if type and count are local variables or field or simple expression, you just plug them in directly. But you can also plug in more complex expressions, including method calls if you'd like. So for example, right over here, this curly brace here and this curly brace over there, that's a hole where you plug in an expression. And the expression goes, if there's only one order, then nothing. Oh, this should have been a question mark, pardon. So if there's only one order, then the empty string, otherwise S. So we get a total of one order or a total of 7 orders. So again, the curly braces just indicate a hole when the compiler should plug the format specifiers. So that's the final shape of this string interpolation feature. I can't say I like it very much. There was another version with a slash curly brace, which I personally preferred, but that's what they settled with in the end. So $, opens a special kind of string where you can use curly braces to specify holes for format parameters. And of course, there's escaping syntax for putting standard curly braces inside a string like that. The technical details are all there. I'm not going to show them to you now. So that's string interpolation in C#6. I could obviously find some opportunities to use this in the service stack Redis code base, but I'm not going to just blindly replace string format calls with this. But for new code, in simple cases like this, I think I'm going to use that from going forward. I probably use that going forward. Next one's nameof, which is a tiny, tiny, teeny feature, but extremely useful in a bunch. Oh, sorry, you had a question, sir. Is that what? Type safe. It is exactly as type safe as string format. Well, what do you mean?
I mean, like if I type is, put a type in a variable, will it fail the compilation?
Or no, but I mean, whatever you put here has to be somehow formattable as a string. And everything is, because everything has a toString method. So whatever you put in that hole, as long as it's an expression, it has a value, and that value can be interpreted as a string. So I don't see where it would fail. If you put here an expression, if you put there, sorry, not an expression, if you put there code which is not an expression, a statement which doesn't have a value, then yeah, it would fail to compile. But as long as you put an expression in here, it's always something. It's always something that can be stringified. If it's null, though, then yeah, it could fail at runtime. Yes?
So what if you refactor and
sorry, what's that?
If we rename the orders variable, will it automatically rename the thing within the string?
Oh, rename. Well, again, presently it doesn't, I mean, the compiler looks into the string. It recognizes the fact that the curly braces open hole for expressions. So the basic refactorings work. Whether, the more advanced, well, ReSharper obviously is going to support it, if not already supports it, but I could imagine some refactoring tools would miss it at first. But yeah, the current editor does recognize the fact that these are holes and there's an expression in it. You also get IntelliSense inside and everything. It's just another place to put code in the middle of a string. OK, so nameof is a really tiny feature which lets you get the name of specific code elements. And this is useful in a bunch of contexts. For example, here's a couple of situations. So property changed handlers usually look like this. You want to raise the property changed event for a particular property. So you go, well, take the property changed event if it's not null, then invoke the event with a new property changed event args, and you put the property name here in quotes. So it's a string. It's not refactorable. The editor doesn't recognize it. The compiler doesn't recognize it. And when you rename the property, obviously this doesn't change. Another example is argument null exception. You throw an argument null exception when the input argument is null. And then you rename the input argument, but you forget to update this thing here, the string. So nameof is just a way of getting the name of a particular code element, like I said. So here's how we can refactor this in C#6. Nameof color, nameof input. You can apply nameof to fields, to local variables, to method arguments, to properties, to methods, to a bunch of things, really, to classes, of course. It just gives you the name of that code element as a string. It's essentially a way of telling the compiler, I want a string here, but you should know it's not just a plain string, it's the name of something. And if you refactor, then obviously the refactoring tools should recognize this. And of course, if you say name of a non-existing code element, it's not going to compile. So you can't just put random garbage in there. So this is really a tiny, teeny feature, but there's so many cases when we use this. Again, in this Redis client solution, I just did a search solution-wide for throw new argument null exception. Just take a look at some of these. It's really helpful, of course, to give the name of the argument that was null, but there's so many brittle opportunities for breaking this code, right? So whenever there's a string like that, someone's going to forget to change the parameter name or change the string at some point. There's literally dozens of these across the code base. And of course, in any GUI app, you'd probably have lots and lots of the property changed event args as well. Yes, sir.
Can this be called outside of the class?
What was that?
Can this name be called outside of the class? Like you want the name some properties in some other class?
Yeah, you can use name of whenever you want. It's just something that always evaluates to a string. Yeah, you can use it whenever you want. It's a constant, it's a compile time operation too, so it doesn't have any overhead. The compiler just puts the string there. Okay, so that was name off. Moving on. Next thing we have, another small feature, is index initializers. And this applies to all collections that you can initialize using this older approach. So dictionaries, but also anything with a writable indexer. So here on the left, a new J object from the popular JSON.NET library, but could also be a dictionary of string to string or string to object or whatever. You create the object, and then you initialize multiple key value pairs by just assigning to them. But this doesn't really happen during object initialization. So the object is fully constructed, the JSON variable is visible now, and only then we access this fully constructed local and put stuff in it. In C#6, there is a new syntax for initializing dictionary-like collections, and that's index initializers. Again, I don't particularly like the syntax they eventually settled for, but that's what we're going to get in C#6 and Visual Studio 2015. In curly braces, we put pairs of keys and values in square brackets. Now, what this does is not equivalent exactly to what happens here on the left-hand side. What happens here is that the JSON local is only assigned after all of these initializations have taken place. So the compiler takes care to create a temporary, make all of these initializations to the temporary, and only when it's done, assign the whole thing back to the JSON local. And when it's a local variable, it doesn't really matter that much. But when it's a shared thing, a field, a property that other code can see, other threads can see even better, then it's obviously important. Here we're making this whole assignment, this whole initialization, kind of like an atomic operation, which becomes visible at once. Whereas here, the construction of the object and the initialization happen in two separate steps. And by the way, it's pretty much the same motivation as collection initializers and property initializers in C# 3.0, where you can do this kind of thing with lists, for example, but you couldn't with index-based collections. Okay. So far we had about 8 or 9 little features like that. Let's see another one, which is incredibly important, but I'm not sure you're going to use it every day. However, when you do need it, it's an incredibly important and useful feature with great applications for debuggability as well. And this one's called exception filters. So check out this code on the left and tell me you have never written anything like that before. So you try something, and then it could throw an exception. But in most cases, you don't care about the exception whatsoever. You only care about the exception in one particular edge case which you know you should expect. So maybe you run some SQL stored procedure, and it fails with this very specific error code. And if it's that error code, you have to handle it. You have to swallow the exception. Otherwise, just bubble it through. So this is how we solve this in C# 5.0. We catch the exception. We check the error number. If it's what we need, we handle the exception. Otherwise, we rethrow. What do we lose by rethrowing here? How does it hurt debuggability, for example? The stack trace, do you remember say stack trace? Yeah, so we're not quite losing the original stack trace because it is part of the exception object, but as far as the debugger is concerned, the exception was thrown here. So we can still look at the original exception object and see the original exception stack, but the debugger sort of thinks the exception originated from here. So it does make it harder to debug, and if you're dealing with crash dumps, for example, it makes it even harder to debug because essentially you caught the exception and then you rethrew it, right? It's not the same exception anymore. It's not exactly the same location anymore. So here's the alternative C#6 syntax, which has additional applications as well. And this is called exception filters. It looks almost the same, right? It's just the if moves outside of the catch block. The if is now a condition on the catch. So we only catch the SQL exception if it also has an error number of 1105. Now, this is something I think was in VB a while ago, wasn't it? I think Visual Basic had this sort of feature for a while, but in C#, it's pretty breaking ground here. And the interesting thing is, the CLR had support for this forever. Windows had support for this forever. This ability of looking at an exception in flight and then dynamically deciding if we want to handle that exception or not. But it wasn't exposed to us C# developers. We could only filter exceptions by specifying the type name. We want exceptions of that specific type or that other specific type. And this also kind of causes an explosion in exception types. You often create exception types, one-off exception types, that you only throw in this one specific place in your application because you want to be able to differentiate and tell this exception I want to handle, no other exception is interesting for me here. So you don't need this anymore. You have exception filters now. You can filter exceptions by any property of the exception, and it doesn't have to be a property of the exception itself. Inside this if, you can obviously run additional methods. You can query the system state. You can do whatever you'd like. It's an if statement, and you can put arbitrary code in it, including method calls. So here's another interesting example. And this is also something I bet many of you have written once or twice. You do something, you catch any exceptions, but you don't swallow them. Obviously, you're not going to swallow any exception. You just want to log the error, and then you want to rethrow. Happened to me once or twice anyway. We don't need this anymore. And we, again, gain much better insight into the origin of the exception by not doing this. So how would you do this? I mean, you want to invoke the error method whenever there is an exception, and you don't want to do it with a catch block and a throw. You want to do it with an exception filter. So how would you use this syntax here to express your intent? Yeah, so just have log error return something. Actually false, I bet. Yeah, so you do something, and then you catch any exception whatsoever, but you don't really. Your exception filter calls a method that always returns false. So this catch block is never invoked. It doesn't ever catch anything. The only purpose of this catch block is the exception filter, which, along the way, will log the error. Now, I know it looks a little ugly, but it's going to become a pattern. I mean, you're going to see people recommend it time and again because it's the only reliable way without catching and rethrowing the exception to process it in some additional way. And obviously, it's not just for logging. It's for any kind of processing, intermediate processing, you need to apply to that in-flight exception object. So this is going to be extremely, extremely useful. And again, let's take a look at a couple of examples. I have another search here, and this time, no, not this one, sorry. Let me run another search. What I wanted to search for is just throw, rethrowing an exception. Rethrowing an exception is going to become an anti-pattern in C#6 because there's no good reason for you to ever catch an exception and then rethrow it because you now have exception filters. So if I just find all occurrences of throw, there's a number of those in this code base. Not as many as you'd think, by the way. But some of these aren't really good. So I have a couple here in queued Redis command. I have it over here. So this is the classic example I've just shown you. Catches an exception, logs it, and then rethrows. So we can rewrite this by making log error return false, or just wrapping it with another method. But there's another example in Redis native client over here, specifically the flush send buffer method. Not an easy code base to navigate. Sorry. So this is flush send buffer, and there's a bunch of code here, but OK. Here's the anti-pattern again. So catch IO exception, but if that IO exception has inside a socket exception, then it's OK. So if it's an IO exception that has inside a socket exception, then we're going to clear the buffer and handle the socket exception. But if it's just a plain IO exception, then no. In that case, we just rethrow. So again, this can be made much clearer by using an exception filter. And in fact, we could also unify these two exception blocks into something like this. So we could say a socket exception derives from IO exception, I think. So we could do catch IO exception if EX is socket exception, or EX inner exception as socket exception is not null. And then in here, we could put this error handling code. Now, I bet it thinks that, the given expression is never the provided type because socket exception doesn't really derive from IO exception. I just thought it did. Yeah, OK, so we can simplify it as much as I wanted to. This was a nice attempt that would have worked if socket exception derived from IO exception. But we can still take this part over here, which does the rethrow, and make it an exception filter instead. Right? So at least that we can do with an exception filter that tests for X inner exception as socket exception isn't null. Yeah?
Out of interest, can you add multiple exception filters or only one?
It's an if statement, so you can use and, chain them. Mm-hmm.
You can use and, but can you have like if, or else? Or
No if else. Just an if that takes a Boolean condition. Just a Boolean condition in there, yeah. But again, you can combine multiple Boolean conditions, like I sort of tried to do here. Mm-hmm. OK. Moving on, I think that was the last. No, we got a couple more, and important ones, nice ones anyway. Next one's called using static members. The code on the left here is, again, obviously designed to look ugly because there's lots and lots of math in it. So I'm calling this square root function, and then I'm calling sine and cosine and abs and log. And I have to keep tacking this math dot in front of each one. And it's in red, so it's obviously bad. So let's refactor this. In C#6, we can do a using for all the static methods in a particular class. This is something Java had forever, and now C#6 has as well. So if I'm using system.math, I can now access directly in that source file all the static methods of the math class without the math designator. So square root, sine, cosine, abs, log, directly. I think it's really nice, especially for simple static functions like that all happen to live on the same type. Another type where this could be useful is system enumerable, which has all the extension methods like where and first and order by. So you could get them all as first-class static methods if you'd like. So this can be extremely useful in certain situations and make for more expressive code. Nothing particularly interesting other than that in here. Yeah, so that was the last one. And now I'd like to talk about the future, so some of the potential things that might find their way into C#7. But before I do that, this would be a good point to stop and see if you have any additional questions from along the way. You can see these are all very small features, but they do have some subtleties, and they can be useful occasionally, occasionally not so much. So just to give you a quick reminder, we have using static, we have exception filters, we have index initializers, which is meh. We have name off, which I really like. We have string interpolation, which is meh. We have null conditional operators, which, okay, yeah.
Yeah, about the string interpolation.
Absolutely, that's why I was doing this.
Is there compile time checking?
What was that?
Is there a compile time checking
Of what?
of the names of the variables you use?
Oh, yeah, it's not so much type checking. The expression inside has to be a valid expression, yes. Okay, we have null conditional operators, which is extremely useful for invoking events, and also extremely useful in general when you want to test whether something is null, and if not, then access a property of it, and if it's not null, then access another sub-property of it, and so on. We had expression-bodied members, which is nice for writing short, simple methods. And we had a couple of features around properties, auto-properties and auto-property initializers right here. Okay, so that pretty much was C#6 anyway. Nothing particularly big here, but I would like to talk a little bit about the plans for C#7, like I said, so I'm just gonna skip back to where we were. Now, what I'm telling you here is not based on any kind of, internal super secret information that I'm sharing with you because I have some sort of internal access. No, these days are over. Language design now happens in the open for both C# and Visual Basic. Now, what does it exactly mean happens in the open? It doesn't mean that you and I can just, sort of make up C# language features, implement them, push them to GitHub, open a pull request, Microsoft takes it, and then we've influenced the next C# language version. Not quite there. But it does mean that whenever the team meets, whenever there is a language design meeting inside Microsoft, they try, in many cases, to record video or to even share it online as the meeting is going. They always post design notes, and they always facilitate feedback. So they always ask for feedback on whatever they were planning in that design meeting. And in many cases already, they have rejected language features. One notable example being primary constructors used to be a feature that was almost in C#6, and it was rejected partly because of community feedback. It was a very complex feature, and there simply was disagreement on how to best make it happen. So what it means that the language design is happening in the open is that you can follow the language design, you can give feedback on the language design, and you can stop bad things from happening. So if you see something that's totally crazy and you don't want that in your favorite language, there is an opportunity for you to intervene. Additionally, the language implementation is in the open, and there we have many more involvement opportunities. Once a feature is designed, once there is a spec, once it's clear what's going to happen, implementing that feature is definitely something we, the community, can do. It hasn't happened yet, so there isn't still a big language feature that made it into the language that was implemented by someone outside of Microsoft. So far, it's been mostly bug fixes and code in the Roslyn platform and not the compilers themselves, but it's definitely going to happen. So the direction is, I think, very much better than what it used to be, where we'd just get, a new compiler dropped on us with a bunch of features we had absolutely no influence on and no insight that these features were coming. So it is going to be much better. What I'm sharing with you, again, is just some preliminary work on the C#7 language. Not necessarily going to be C#7, could be even later than that, but it looks like it's going to make it into C#7. One such feature is record types, tuple support in the language. Record types is another coming up next. tuple support in the language. And one proposal looks like this. A method would be able to return a tuple specified like this, an int status code and a string body. And this thing is just syntactic sugar for a tuple of int and string, which you already have in the .NET framework since since .NET 4, I think. This HTTP GET method, like I said, returns a tuple of int and string, and you can deconstruct that tuple into new local variables by using this new syntax again, var sc and var body. So you take the tuple returned by HTTP GET and you deconstruct it into the sc and body variables. And this would apply to any method that returns a tuple. So you could always deconstruct a tuple like that. That's one proposal. That's one potential syntax. It kind of mirrors what we have in other languages. For example, Swift, Apple's Swift has very similar syntax for tuple returning methods and for tuple reconstruction. Most functional languages have some kind of syntax for tuple reconstruction like that. So it's really a useful feature that simplifies a lot of code. And there's a couple of links here to discussions on GitHub on what this feature might look like in the future. Another thing, which is kind of even an extension of the previous one, is record classes and type constructor matching. And this was something that almost made it into C#6, but was rejected just a few months ago and will not be part of the C#6 language. So first here, we have record types. A record type is just a type that has a very specific structure. And I mean, we've all written dozens of record types before, we just never called them record types. Or we didn't in C# call them record types anyway. So it's just a type that has a very well-defined number of fields, and it's initialized from a collection of those fields. It doesn't have any clever behavior of its own. It's just a collection of its fields, maybe a couple of helper methods as well. So here's an example of a point record type, which has an x coordinate exposed as an x property, and the y coordinate exposed as a y property. So the capital X and capital Y here are the property names, and int x and int y, lowercase, are the constructor parameter names. And the syntax is really compact. Now, to create record types, you don't use new in this proposal. Again, it's all just, theoretical, hypothetical proposals for some future version of C#. So you wouldn't have to use new for record types. You just say the type name. And even in a nicer fashion, you'd be able to deconstruct the record type and do pattern matching. And here's a simple example. You could ask if this object here of type point has the structure of point, and then the first part of the point is anything, but the second part, the y, is 0. So this is you can think of this as another way of saying if center is point and center.y is equal to 0, but another way of looking at it is not as just a plain Boolean expression, just a plain if statement, but rather as pattern matching. You're looking for a specific pattern, and the pattern is the y is 0, the other part you don't care about. And again, it's something functional languages have, all of them have, and are really proud of. Some of them take it to the extreme. For example, if you look at Haskell, it has, half the syntax is around pattern matching probably. And what makes it possible is that the classes, the types, have a really well-defined structure, so-called algebraic types. And record types in C# would make this kind of pattern matching possible. And this goes even further in another proposal, which expands this to switch statements as well. Again, in a hypothetical future version of the C# language, you could do really incredible stuff like this. Suppose you have an expression type, an expression record type, which has some subtypes. You have expressions for addition, expressions for multiplication, constant expressions, null expressions. So you could write a method that evaluates an expression. It takes an expression and then pattern matches on it. Could be a null expression, in which case a val returns null. Could be a const expression initialized with some value x. So this is deconstruction. You take an object and you deconstruct it. If it's a const expression, then it was initialized with some value x, and you want that x. You only want to extract that x. In that case, you return x. Could also be an addition expression, which has two sides. It's a binary operator, binary expression. So an addition expression has a left-hand side and a right-hand side. And so again, you could deconstruct this thing and get the left-hand side and the right-hand side expressions, and then evaluate them recursively. And finally, you can also do some sophisticated pattern matching like this to recognize the fact that multiplying 1 by anything returns the same value. So you could say, if it's a multiplication expression, and inside, on the left-hand side, you have a constant expression which was initialized with the number of 1, then just evaluate the right-hand side. Now, this all looks crazy if you haven't done functional programming before, but if you've used Haskell, scheme, any kind of Lisp really, F#, it's part of the syntax. It's such a fundamental part of the syntax that you can't really imagine using anything else. If this gets anywhere near C#, this could have really interesting consequences. And it's not, I mean, no one wants to make C# a pure functional programming language. There's enough of those. But adding this kind of pattern matching features, for example, or record types or tuple handling to the language is one of the key directions that Microsoft anyway is considering. There's many pages of notes on this subject. There isn't a clear set of features that will definitely be in the next language, but I'm willing to bet that something will eventually emerge out of all this. And if you look at newly designed languages from the recent years, again, such as Apple's Swift language, pattern matching is a key part of that. And if C# gets this kind of syntax, it's going to be pretty exciting, I think. So again, there's a bunch of design documents linked here if you'd like to read more about the current proposals. But again, just to clarify before we move on, this is all hypothetical, not based on any internal secret knowledge. It's just what's in the open on GitHub, and it looks like this is the direction things are moving in. And in any case, once Visual Studio 2015 is released, everyone at Microsoft is going to have so much free time on their hands that I bet there will be lots of investment, public investment as well, in the evolution of C#. At this point, everyone I know on the C# compiler team is extremely busy fixing last-minute bugs with Roslyn and talking to customers and all kinds of annoying things like making builds for public previews and stuff. Once that's behind us, C#, it's going to be interesting for C# developers. So it's a bit early. We still have about 25 minutes, but it's never a bad thing to finish early. If you do have questions, however, we have some time for a discussion. So if you'd like to ask anything, please feel free. What is Roslyn what? Well, what does Roslyn mean for us? First of all, it's very good news that Roslyn is done, because it's been hanging over our heads for a few releases, and it's been actively preventing Microsoft from making progress in certain areas. So it's a very good thing it's done. You can think of it as an internal project that was taking lots and lots of resources. So the fact it's done is a good thing from that perspective. Now, in terms of performance, it is not a faster compiler at this point. It also does not generate better code at this point. But it has the potential to. I know it's not very reassuring, but it has the potential to, and it will. The current code base, the C++ code base for the C# and VB compilers was out of hand. And making any considerable investments to it, from what I hear, was pretty hard. So it's, again, a good thing that there is a clean code base they can work on. What it does give you right in Visual Studio 2015 is the new C# language features. Similarly, there's new VB language features and a better IDE experience. So some additional refactorings, code fixes, a faster, smoother IntelliSense, that kind of thing. The compiler itself, no. At this point, I wouldn't hope it's like 5 times faster or produces better code. Probably not going to happen by preview. Yeah. So that's for Roslyn. I hope you appreciate it was an honest answer, not trying to sell you anything. Okay. Yes.
Is there any news on when this is going to actually be released?
Plans to?
Is there any news when this is likely to be released?
What, the whole product?
Yeah.
I don't know. Well, I mean, CDP 6 just came out a few weeks ago. I think the next step is a release candidate, but I don't have, nothing to base it on. I think that given we have a build in San Francisco early April, and Ignite, which is the TechEd replacement in early May, it would make sense to release something along these two conferences. That's what the past teaches us. Yeah. OK. Well, if you do have any additional questions, I'll be happy to talk to you privately. Thank you very much for coming. Enjoy the rest of DevWeek. Thank you. Inside Microsoft of the Roslyn project. And Roslyn is a re-implementation, essentially a rewrite from scratch of the C# and Visual Basic compilers in C# and Visual Basic. The former versions of these compilers were written in C++. And Microsoft still maintains those older compilers written in C++, but Roslyn, the project, was partly about building a C# compiler in C# and a Visual Basic compiler in Visual Basic. And along with other things, it helped Microsoft really refine their understanding of those languages, corner cases, and how these languages can be used for a huge production code base. Furthermore, Roslyn is not just the compilers. It's also a platform for building code analyzers, for building refactoring tools, for building code fixes within the Visual Studio editor, for extending the editor itself. So there's a bunch more things you can do with Roslyn. But what I wanted to tell you about right here is that the new C# language, the new features in C# 6, are so small and incremental, I think, partly because Roslyn was such a huge project and they wanted to get it out of the door. They really wanted to get it over with and then start thinking about the next huge feature for the next version of the language. And again, it might be coming in C# 7, but in C# 6, there is no such huge feature. One more thing before we get started is that Roslyn, the compilers, are all open source now. Since November, they're open source. They've just moved to GitHub, and you can go and get yourself your own impression of the product. If I just quickly open a browser and go to the Roslyn project on GitHub, you'll find first that it's pretty active. So if I go to the pulse section, there have been, over the last week, 94 commits, excluding merges, on master, and 230 commits on all branches. 978 files have changed on the master branch with dozens of thousands of additions and deletions. There's a bunch of people working on the project, and not all of them are Microsoft employees. There have already been contributions from the outside by Microsoft MVPs and other people with no association with Microsoft. So it's a really impressive thing, this open sourcing of the C# compilers. But again, I think it's partly the reason why the language didn't get as many cool, exciting, huge new features. So let's get started with a couple of them. Now, if you have any questions, then please ask, because we're going to be moving from one feature to the next, and they're not all interrelated. So if you miss something, we might not have another point where we come back to it. So the first feature I want to show you is a really small one, but a very useful one if you've been doing async and await. And that's support for await, service stack, not stack exchange. And then try and add, occasionally, some uses of C#6 features. So just to give you just this general idea of where C# is going and where we're coming from, this is the evolution of the language since C# 2.0, which is the second version of the language, the third, if you will, if you consider C# 1.1. And so C# 2.0 main feature was generics. We also had anonymous methods and a couple of other things concerning delegate contravariance, but basically generics. C# 3 was really lambdas and link. The key features were lambdas and link, and that was a huge release, right? After C# 3.0, you had lots and lots of new features to learn, and reading new code was rather difficult at first. C# 4 introduced dynamic, which is an okay feature, but I bet you're not using it every day, at least most of you. And there are some additional smaller features as well in C# 4. C# 5 has async and await, which are huge, and for some kinds of applications, you're probably writing async and await every day. In other apps, maybe not so much. And so the question we all had a couple of years ago was, what's next for C#? So what kind of huge, big feature they're going to tackle next? And many people had their own suggestions and ideas. For example, many people from the functional languages side were pushing for more FP-like features in C#, especially in welcome to the practical C#6 talk. I can see some familiar faces already. So I'm just going to introduce myself briefly. I'm Sasha Goldshtein. I live in Israel. I work for a company called Sela. And this talk is on C#6. And what I've tried to do is kind of make it a little more interesting by showing you how you can take existing code and start to benefit from adding C#6 features to it, and not just, you know, a syntax review of what we have coming up in the new language. Another thing I tried to do is gather as much information as I could about what's coming next, about what's going to happen in C#7 and possibly even beyond that. Because C#6, it is new. It's not even released yet, but it's kind of old. We've been told about some of these features about 2 years ago already. And in some cases, there haven't been even any significant changes to the feature design. So some of these are really not quite new. Now, I realize we're not using them in our everyday C# code because they haven't been released as part of Visual Studio yet. And that's part of why this talk sort of try to show you how these features can be used in an existing code base. So what I did is take a Redis client developed by Stack Exchange. It's an open source implementation of a C# Redis client influenced by F#, stuff like records and tuples and pattern matching and a bunch of type constructors, a bunch of other interesting things. But none of these are actually part of C#6. There isn't a single huge breakthrough feature in C#6. It's a set of smaller improvements, incremental improvements to the language. Some of them were driven by customer feedback, people asking for these features for a while on user voice and other forums online. And some of these features Microsoft just sort of came up with on their own. The C# design team has been meeting every week for a while now, and they have a pretty good idea of the direction of the language, but there isn't a single big thing that I could tell you, this is C#6. There's a bunch of smaller features. The biggest focus, though, was on developer productivity. So many of these features really have developer productivity in mind. And what I'm going to do, actually, for each feature is try to show you the old version of the code as you'd write it in C# 5.0 and what you can do in C#6 to make yourself and the code more readable, more productive, and so more efficient, and so on. And again, as we go along, I'd also like to show you maybe a few examples in Visual Studio 2015 as we take existing code and sprinkle around some of those new features. And one more thing before we get started, I do have to mention the Roslyn project. So really, Visual Studio 2015 puts an end to a very, very long development cycle